video is going to be about the oceans. As you can see from here, very nice panoramic view of the oceans. We are in Santa Monica Mountains, Santa Monica Beach over here. You can see Santa Monica Piers on the right left side over here, clean. Far behind you can see part of some other places like the Manhattan Beach. You can see Venice Beach, Venice Beach, and you can see behind the beach that is very close to the airport, Los Angeles Airport. Behind you can see over there the Catalina Islands, far behind. We're going to talk about the ocean, especially the origin of the oceans. First of all, we have to analyze the composition of the ocean. Is about 45% is chlorine in the waters of the ocean. The composition of the water of the ocean, 45% is chlorine, and then 31% is sodium. We have an 8% of another ion that you call SO4. And then we have about calcite, about 4% in the water. 1% is potassium. Some other minerals. But those are the main ones that I mentioned before. And this is the Pacific Ocean that we're watching at this moment over here. Far in my right side over there is what they used to fill the cities that is called one of the cities that was very popular back in the 90s, 80s and 90s. It was filmed here in Santa Monica, also in the place that is very close to Santa Monica on the right side. The important about the ocean is that we had 5 different oceans. The bigger ocean is the one that we see now this moment. This ocean is about to 43% is covered by the Pacific Ocean. Then we have the Atlantic Ocean in the north. It's about 23%. Then we have the Indian Ocean, that is about 20%. We have the Arctic Ocean, that is about 4%, and the Antarctic Ocean, that is about 6%. That is the composition of the planet. The ocean covers about 362 million square miles. It's a lot, because the whole surface of the planet is 510 million, roughly 510 million square kilometers. Compared with that, we have about a little more than 70% of the surface of the planet is covered by the oceans. One of the things that we have in the ocean is that we really don't know, the bottom of the ocean. We have explored about 10% of the ocean. Most of the ocean is we don't know what is down there very deeply. The maximum deep that we have is in the Mariana Trench, that you call. It's one of the subduction zones in which the plate tectonics tend to go down the crust, and that form immense. It's about to 11, a little more than 11 kilometers, the depth of the ocean in those parts over there. The average of the ocean is about 3.5 kilometers. Now, you can see from here where you are looking at now is part of the shore of the land. This shore is a couple of kilometers, and after that we have a very steep dip that they go to the 3 kilometers, but they're talking about 3.5 kilometers. The origin of the oceans happening, it's very difficult to say, but we know by the evidence that we have in the rocks and evidence that the ocean almost, first of all, the 4.5 billion years that have the planet. At the beginning, we were very, very hot, but only 100 million years after the formation of the planet, we thought that the ocean, we had a lot of water already in the planet. So we pushed also before we discovered that we had before, back talking about before the 70s, we thought that the ocean formed far later from the beginning of the planet, but not. We discovered that it almost wasn't the beginning. And evidence, we have bacteria that growing 100 million years after the ocean. That's point the light much sooner than we expected, in the ocean. So we have a specimen slide that we have in the bacteria, special bacteria. Most of the time that we have in the life in the planet was bacteria and was growing in the ocean. This bacteria, this bacteria was called cyanobacteria, and this bacteria appeared almost 100 million years after the ocean was formed. So, something spectacular happening, with this bacteria. Before we didn't have any oxygen in the atmosphere. The atmosphere was loading with carbon dioxide from the volcanoes and from the beginning of the planet too. A lot of carbon dioxide in the formation of the planet. And we discovered this bacteria that was taking the carbon dioxide in, and in return was giving oxygen. So that process, happened for millions and billions of years, in which the bacteria was producing the oxygen, and that is the oxygen that we have in the atmosphere now. So the carbon dioxide was replaced by the oxygen that this bacteria was exhaling out, inhaling the carbon dioxide. Made possible, and that's cleared the atmosphere, made it possible for the light to go in the land. About to 650 million years. We have an ice age that was covered, the whole planet was covered by the ice, what we call the snowball of the planet, the whole planet. After that, it took about 10 million years, the planet with that ball of ice. The scientists couldn't explain why this ball of ice returned, to the normal, because once the planet get covered by the ice, all the heating that is coming from outside, from the sun, that keep a lot of the environment that we have, is reflecting back. So they were puzzled, by the idea how they did, and they couldn't discover, but they couldn't explain the thing. And then one scientific from Caltech over here came to his mind, and found some evidence too about the carbon dioxide for those 10 million years. Carbon dioxide from the volcanoes was accumulating, and that made the planet, in very short time, with melting all the ice, and then become able to, the bacteria that was before evolved greatly during those 10 million years. It seemed that the planet was covered in the top, but in the bottom all was some kind of bacteria that was alive, and then this bacteria evolved during this time, and then when we had the Cambrian explosion about 640 million years ago, the Cambrian explosion, in which We have a lot of different lights in the oceans. Trilobite is one of the most common little animals that is the ancestor of the frog that we have now. They grow for all over the planet, as well as so many other species that grow on the time. And the bacteria that was for all the billions of years before was only bacteria, microscope. And then in the Cambrian explosion started appear those trilobite, and start to appear millions of other species too. With a little big body now, you know. And that's we have a lot of those fossils around. They're very common to find in the mountains, to find everywhere in the planet. Also, the calcium carbonate was created by this bacteria for billions of years. And this bacteria was dying in the top of the ocean, and then we're thinking down, and then form the sedimentary rock they found, and this is what we call now calcium carbonate, and marble, many of those stones that we use now come from those bacteria that grow billions of years. Also, the methane hydrate that we call from the death of those bodies, that bacteria, was accumulated in the ocean. Billions of tons accumulation of those bacteria. That's the natural gas that we have now. A lot of the natural gas was produced in that thing. So after the Cambrian explosion, about 400 million years ago, then the light started to spread from the planet. One, we have the atmosphere created by the bacteria inside the ocean. We have the ability the animals were able to come to the continents and then colonize the whole continent, all the continents around the planet. About 400 million, that transition happened at 400 million years ago. When we had these species to spread for all over the planet, to spread for all over the planet too. And also there was a period about 100 million years after the animals, in the same period of the Cambrian explosion, the ozone layer that protect from the ultraviolet rays and from other rays that come from the sun or from the cosmic rays that come from the star. It was creating this ozone layer. This is about 30 kilometers from here, from the ground to over there. There is a layer that is called ozone layer. That is kind of oxygen, heavy oxygen. It's 3 oxygens together. You know, that was a result of the oxygen that we have in the atmosphere start to decompose by those cosmic rays and form this oxygen tree that we call that is the ozone, and that gave a lot of protection to the light to the cells that was coming outside the ocean. Before, those animals, you know, they live in the ocean were protected by the water. The water protect them from get damaged. And after that, the ozone layer was created. It took about 100 million years after the atmosphere was complete to create the ozone layers. We now can count those exactly. It's about 3,000 billion tons of this oxygen, heavy oxygen. This around the planet, 3,000 billion tons. This is the ozone layer that we have now. It's a very tiny layer. It become very, very tiny. But it's the one that provide the chill from the cosmic ray and from other rays that other way it's very difficult for us to live over here. So just put in consideration how long it stays for the planet, you know, to get able to sustain the life and the variety of species that we can see now. But what we can see now is just a tiny amount of species. Through the history of the planet, we have billions and billions of different kinds of species that we've been having in this planet. We the humans appear about 3.5 million years ago, we have evidence of the some of the that look like us, that start to walking right, and they have a hefty capability in the brain that we have now, but they already start to staying up, walking to feet. That was found in Africa, some of the places over there. We have a strong, very evidence, definite evidence that these animals exist at the time, and we almost sure that we depend on this client the thing, because we've been followed through the history of those 3.5 million years, how we've been having different species, hominid that we call. We live in many times the history, about million years. We have about 20 different species like us, but no with the same DNA that we have now. The last of these species, it was about 30,000 years, 28,000 years disappeared, the Neanderthal, and then we were the only one. At least as we know. This is why it's been tell the history. So we have to have when we see this immense amount of water that we have, immense amount of time that the planet takes to evolve, we have to be humble. Don't think ourselves like we are the maximum thing, that we are the king of this planet. Some of the species disappeared, but very, very fast. So the thing that we can do to survive is the cooperation, the cooperation of the species for all over. And finally, we have to be able to find a way to get up on this planet, like Elon Musk is thinking now. And when we compare the technology that we are now with, in the last 150 years, we have advanced so much, like never before in the history. We discovered so many things with the big instrument that we discovered. That's make us look at the future, and see the great possibility that we have that we evolve as a species. The knowledge is so immense. We just beginning to understand this planet, the galaxies, the formation of the planet. One of the planets that puzzles us, is Venus. It's about 10% less than the planet Earth. But we're expecting to find something different on the big cloud, the carbon dioxide that exists over there. Some of the people speculate before, some of the scientists, that there were a lot of light, because supposedly we start at the same time. Most of the planets start at the same time, the formation of the Earth, at 4.5 billion years. But it happened, it's very difficult to explain Venus, because Venus is the way how they saw Venus over there. Now that we have some probes over there, different probes and studies from the atmosphere over there, they have a very thick atmosphere with a lot of carbon dioxide, and in the surface it's like volcanoes, like the planet, like the planet Earth, what only have 100 million years old. So very, very difficult to explain, and we don't have the scientists don't have any idea, how Venus is, the evolution of Venus. Very, very difficult to explain. So we barely start to understand who we are, where we come from. Another thing that is peculiar in these things is that we have seen some deformation of the stars in in those big clouds that we have. Big cloud that we have in the when we look at the telescope, in the same galaxy that we have, not outside the galaxy. In the same galaxy that we have, I have about 100 billion suns like the one that we see every day, 100 billion suns. In this galaxy, we encounter, we see some big cloud We know that those big clouds is where the formation of the star take place. When the nuclear reaction, the fusion take place with the pressure, the gravitational pressure and some other big forces that exist, there's that the formation of the star. So we have seen some of those stars from the beginning, that the formation, and we see how some of those stars much bigger than our suns. They say 1,000 times than our suns, bigger than our sun, and we see the beginning of those stars, how the water from the escape from the planet, at the formation, going and the rotation of the planets, can escape from the poles of the planet, and it's immense amount of water that is coming from those poles for the rotation, and the formation of the planet. It's coming outside, and that's formed later on from the ocean. That is water vapor that escape from there. But immense amount. Some of the scientists calculate that it's like the whole ocean in the planet. Every second that's coming from those big clouds when they form those big stars over there. Well, so we have a clue now with the technology that we had this capability to understand how the sun form, how the star form. The sun is the same as a star. Our sun is a star. A very small star, it's not a big star. But it's the star that we have now. NASA, about 4 years ago, make a public, that we have about 40 billion planets. Yes, in the galaxy that we have, and there's a 100,000 billion star that we have. So in this, we have in our galaxy alone, we have up to 40 billion planets that have the condition of the Earth. That was estimated by the big computers. So, life for all over the galaxy, probably. Definitely, when we see this amount of planet, and the condition are the same. And another thing that we have to take into account is that the gravitation law, and all the laws that we have here that apply to our light over here, is the same laws that appear in the universe, in the whole universe. Now that we had the chance to explore more, take a look at those things. So that's why we are very optimists. We have to be optimists because the knowledge is so immense. One day we're going to be able to control many of those forces, much more. Like we want to encounter many other mysteries that we don't know now, but they exist over there because the knowledge is kind of limited amount of knowledge that we have. It's immense. So take a look at the ocean over here one more time. Look how the people enjoy this view over here and enjoy the beach. It's a Saturday now. It's a lot of people, even when it's cold, the people are still going in the beach over here. Look, thousands of people around there. Many another playing skateboard. And this is a little park that we have. Some people come over here. You have to have a great afternoon to see the sun down. And it's beautiful for all over here. So here is a place where I used to do exercise, especially under that big tree that you see over there. When it happened in Los Angeles, I used to come over here to do exercise. And many people from all over the United States come over here, and from all over the globe too. So it's come over here, Santa Monica. It's a very beautiful place. And it's a lot of fun that happens here. You can bring your family, and it's very important that we teach to our kids, to especially Hispanic people. Most of them, they like to stay in the same place around downtown LA and never bring their kids to enjoy this kind of view. Even when it's very close, to Los Angeles, there's a lot of buses that come over here. You have your car, you have the parking. So this is another video. It's kind of long video, but it's another thing that we have to understand is that we have to, in order to understand the universe, in order to understand this technology that we have, developing all those cars that you see down there in the Pacific Highway, the aeroplanes that come from the different places, from the airport over here, in order to have these things and understand the thing. That's why we go to the schools. There are some special interests that they wanted that you become accustomed to only pay attention for a few minutes only, you know. But that is intentionally put in your minds, in our mind. When you go to the school, you have to stay at least 1 hour, you know, 50 minutes with the professor over there explain you, and you have to listen to this person all the time, you know, for 50 minutes at least. And then you go to another class. It's just in elementary school. You have 2, 4, 5 classes at the same time, you know, and go from one teacher to another teacher, and always spend a long time. But that is the commitment that we have to have in order to understand many things. So just to listen a video, don't go and sleep, you know, when you listen a very important video that we have now on YouTube and for all over, and people who really care about the development of humanity. We have to get used to listen to those things. We have to get used to read, you know, the textbooks that we have for study, serious study. You have to spend many hours every day to pass the class. We have to teach our children, you know, that is the way how it goes. If you want to learn, you have to have a discipline. Otherwise, we don't learn anything, you know. Just to go in the basic elementary school, it's about 5 years over here, elementary school, that you have to go. Wow, it's yeah, and that's commitment, you know, you have to do every day in order to advance. But we have to create that mentality in our kids that it's possible. We have to do the effort, you know, and the kids have to see us, that we spend the time to learning something that is valuable, something that is going to be able to give something to humanity for us to evolve. Not everything, like you say, you know, it's being put in our mind that everything wrong about them. Our kids, they want to be baseball, they want to be basketball, they want to play soccer, like we call over here football, many other things, but that is not the goal of the life. You know, humanity evolved by the technology that we have, but we understand the big thing. So we spend so much effort in the things, trying to convince the kids that the only thing that they can do is play basketball or play other things. No, there are books over there. They have to spend the time to reading if we want to evolve. You see, with sport and everything, we don't go that far. You know, we only be the same planet over here. We're never going to advance in the things. So realize that thing. Wake up about this thing that we're putting us. You know, we have to do all that we have to do is play baseball, and then we're going to make a big box. And I think no, that is much more interesting. It's much more. You know, it's go to the universe. It's much more. I mean, if we want to evolve, if we want to go forward and understand the real thing, we have to encourage our new generation to study and to be disciplined too, to learn and to work, to create things. It takes a commitment, immense commitment for this, for make the society great, and make this society is not think of the people who just believe that everything is going to be free. No, you have to work for it. You have to work for it, and you have to gain these things. You have to gain. You have to. That's the way how we evolve. When we do something that made humanity evolve. Thank you very much. I'll see you in the next video, and I hope you learn this thing that we have to actually really commit ourselves to the goodness. You know. Thank you. Bye.